Welcome back, fellow mathematicians. In this video, we're going to talk about the distributive property, but how we can use an area model instead of arrows to multiply. So the distributive property states that A times the quantity of B plus C equals A times B plus A times C. And you can see how the area model looks with a box. And we're basically finding the area with a length of A and a width of B plus C. So let's talk a little bit more about what it means to distribute before we take a look at some examples using the distributive property. So distribute actually means to deal out or to multiply. And you might have heard of this through distribution centers, right? That's something in common in our real lives where distribution centers actually deal out goods throughout our states, country, throughout the world. And in math, we can see an example like we have on the right, which is 2 times the quantity x plus 1, where we're distributing the 2 to all terms inside the parentheses, or we're dealing out the 2, right? 2 times x is 2x, 2 times 1 is 2. So if you forget what distribute means in math, just think back to the real-world connections you have about distributing meaning to deal out. So now you're probably asking, how do I use the distributive property? All we're going to do is distribute the term outside of the parentheses to all the terms inside the parentheses. You could have 2 terms, you could have 100 terms. It doesn't actually matter. We just have to make sure that term outside the parentheses is multiplied to every single term inside the parentheses. And today we're going to do that by using the area model. So we're going to take a look at several examples, starting with distributing a positive number. In our first example, we are going to use the area model to distribute a 2 into all the terms inside the parentheses. So our example is 2 times the quantity of b plus 3. So using the area model, we are going to create a rectangle and label the dimensions. So we have a length of 2 and a width of b plus 3. Notice how I cut that box where the plus 3 is. Then we just multiply. 2 times b is 2b, 2 times 3 is 6, and what's inside the box is the answer, so 2b plus 6. Taking a look at our next example, again, we're going to draw that box so that we can find the area of the expression we have because we're letting the terms be our length and our width. So we have 5 times the quantity of x squared plus 6. We're going to put 5 on one side, x squared plus 6 on the other. Draw a line segment in the box to separate terms and multiply. So 5 times x squared is 5x squared, 5 times 6 is 30, so our answer is 5x squared plus 30. Are you getting the hang of it yet? Let's try one more example with a positive number we're distributing. So here we have 4 times the quantity of 2n cubed plus 5n minus 1. A few more terms. We're just going to have an extra line in our box. So we have 4 on one side, 2n cubed plus 5n minus 1 on the other, and draw 2 line segments this time and multiply. 4 times 2n cubed is 8n cubed, 4 times 5n is 20n, and 4 times negative 1 is negative 4. And that gives us an answer of 8n cubed plus 20n minus 4. So even though we had a few more terms here, it's the same process. We're just finding the area of that model. So now we're going to take a look at distributing a negative number. It's going to be the same idea, except this time we just have a negative number we're distributing, and we just have to remember those positive and negative multiplier rules. So in this first example, we have negative 2 times the quantity of b plus 3. So we're going to put negative 2 on one side of our box and b plus 3 on the other side. I just always like to make the smaller one on the left-hand side. That's a personal preference. Then we separate our terms where the plus or minus sign is. We have negative 2 times b, which is negative 2b. Negative 2 times 3 is negative 6. So our final answer is negative 2b minus 6. So for example 2, with distributing a negative number, we have negative 5 times the quantity of x squared plus 6. We draw our box, we put the negative 5 on one side of the box, x squared plus 6 on the other side, and draw a line segment in the box separating our terms. Negative 5 times x squared is negative 5x squared. Negative 5 times 6 is negative 30. So the simplified answer is negative 5x squared minus 30, what we have inside our box. Let's do one more example. So in example 3, we have the expression negative 4 times 2n cubed plus 5n minus 1. Draw our box, make it a little longer because we have 3 terms inside the parentheses, and put negative 4 on one side and the 2n cubed plus 5n minus 1 on the other side. Draw those line segments to separate your terms and get to multiplying. Negative 4 times 2n cubed is negative 8n cubed. Negative 4 times 5n is negative 20n, and negative 4 times negative 1 is plus, right? Positive 4. So the final answer is inside the box. We have negative 4 times the quantity of 2n cubed plus 5n minus 1 equaling the negative 8n cubed minus 20n plus 4 that's inside the box. For some reason, I just rewrote the problem, so that was a careless mistake I didn't catch, but the answer is what's inside the box after we multiply. Before we take a look at our next example, let's review some multiplication rules. So when you multiply, you either get a positive or a negative number. Multiplying 2 positives or 2 negatives results in a positive outcome. Multiplying a positive and a negative will get you a negative number. So keep that in mind as we look at our examples distributing a variable. So a variable is just a letter, and we still multiply the same way. We're just going to have letters in our answers, and that's okay at this point in our algebra. So our first example, we have the expression x times the quantity 3x plus 1. We still draw our box. We still put the x on one side, the 3x plus 1 on the other, and separate our box where the plus or minus sign is in our term, and multiply. X times 3x is 3x squared. X times 1 is positive 1x. So our answer is 3x squared plus x. Not too bad, right? Like, this is very similar to what we've done in our previous examples. You might be a little frustrated that we have letters, but it's okay. And here I'm just showing that you can actually draw your box differently, even though I don't prefer it. You still put one term on one side, the other term on the other, split your box where the terms separate, and then multiply. And here we still see that we get the answer 3x squared plus x. So if you like that better, go for it. But I'm going to do all the rest of my examples the way that I prefer. So example 2, we have the expression j to the second power times the quantity of negative 8j plus 4. So we draw a rectangle, we put a j squared on one side, negative 8j plus 4 on the other, split our box with that plus 4, and multiply. Now j squared times negative 8j is negative 8j cubed. J squared times 4 is 4j squared. So we get the answer negative 8j cubed plus 4j squared. And that's because when you multiply like bases, you add your exponents. So keep that in mind as we do our final example with variables. And this one is b times the quantity of 4 plus 5. So we put b on one side of our box, 4 plus 5 on the other, and draw a line where that plus is. B times 4 is 4b, because we like the number in front. B times 5 is 5b, so we get 4b plus 5b. But you might be thinking, can't you simplify this? And you would be correct. If you didn't know we're combining like terms here, you can check out the video I made on how to combine like terms. But essentially, 4b plus 5b is just 9b. And that is how we distribute a variable. So you guessed it, we are going to finish with distributing a number and a coefficient. So when you see these two final challenge problems, I'd like you to pause the screen, try the problem on your own, and then come back and watch and see how you did. So our first example is 2y times the quantity of negative 3y plus 9. Draw your box, put your 2y on one side, your negative 3y plus 9 on the other, split your box up where your terms are, and multiply. 2y times negative 3y is negative 6y squared. Add those exponents, right? 2y times 9 is 18y, with a plus right there, because it's a positive number. So our final answer inside the box is negative 6y squared plus 18y. Our final example, it's a long one. You can do this, but I think you should pause the video and try it out on your own and come back and see how you did. So yes, I know, I put fractions, I put negatives, I put variables, I put it all. If you can do this problem, then that tells me that you have a pretty good understanding of how to multiply using the area model. So we're drawing our very long box, and we are trying to write teeny tiny because I write pretty large. So we put our negative 1/2 a squared on one side, and the 4a minus a squared plus 10a plus 6 minus 8 all on the other side, and we're splitting up everywhere we have terms separated. And terms are separated through minus signs and plus signs. And now we get some multiplying going on, right? Negative 1/2 a squared times 4a is negative 2a cubed. Be very careful here. Double check your work. Go slowly if you need to. It's okay. Negative 1/2 a squared times negative a squared is positive 1/2 a to the fourth. Negative 1/2 a squared times 10a is negative 5a cubed. Negative 1/2 a squared times 6 is negative 3a squared. And negative 1/2 a squared times negative 8 is positive 4a squared. Now our answer is what's inside that box. But we do need to combine our like terms. And so I like to color code. I got my blue squiggle going on with my a cubed. I'm going to combine those terms. A to the fourth is all alone, no other like terms, that's fine. And then I have negative 3a squared and positive 4a squared. So I'm going to combine like terms, and I'm going to put it in standard form where I start with the highest exponent and go to the lowest exponent. So I get 1/2 a to the fourth plus, and I'm just grouping my like terms together so I don't make any careless mistakes. Because sometimes when you're learning, the more you try to do in your head, the more likely you are to do something really silly. And so putting it on paper can help prevent those mistakes as you're starting out. So we get 1/2 a to the fourth minus 7a cubed plus a squared as our final answer. How'd you do? Did you get it right? If you have any questions, let me know and I'll get back to you when I can. And I just wanted to finish this video with a review on the distributive property. The distributive property says that A times the quantity of B plus C is the same exact thing as AB plus AC. Today we learned how to use the distributive property using an area model where we create a box, put our dimensions on either side, and we're multiplying our length and width to get the area of that expression. And that is going to give us the answer to our multiplication problem. Now, if you'd like to check out my other video where we use the distributive property using arrows, you can. Personally, I do just use the arrows, but they're the same process, right? We're just multiplying the term on the outside to all the terms on the inside. So whichever method helps you do more problems correctly is the best method for you. And I hope that you feel really good about distribution today, and I appreciate you watching this video. Thanks again for watching. And let me know what you want to see explained in the next video by leaving a comment down below, and I'll calc you later.